All right, good afternoon, everyone. Thanks for showing up for this year's celebration of the Shirley Phillips No-Till Award. It's my pleasure to introduce this year's recipient, Dr. Humberto Blanco, who's been at the University of Nebraska-Lincoln for quite a while now, your whole career, perhaps?
11 years.
11 years. So Humberto is originally from Bolivia. He received his Bachelor's of Science degree in Ag Engineering from the Technical University of Oruro. He majored in soil science. He then came to America and got his master's and his PhD in soil science at the University of Missouri. He specialized in applied soil physics and soil and water conservation. At Nebraska, he currently teaches principles of soil management and plant nutrition and nutrient management. He researches topics including crop residue management, cover crops, conservation tillage, dedicated energy crops, biochar, and other organic amendments. He's the associate editor for Bioenergy Research, SSAJ, and Agronomy Journal. Been very active in the Soil Science Society of America, and he's currently, recently, chair-elect of the Soil and Water Management and Conservation Division. He has over 200 publications on soil management and has an H-index of 50 for those of you who care about that kind of thing. It is my great pleasure to hand over to Humberto.
Right, I feel so honored to be standing here. This is just impressive. I'll be at lots of words here, but this is really a great opportunity for me to talk about something that I really love, which is no-till management. So what is, right? So before I start talking about the specific topic, I would like to tell you a little bit more about myself. Thank you, Rebecca, for the great introduction. So I grew up on a farm in the highlands of Bolivia. I was born in a place it's about 12,000 feet above sea level. So then when I saw my dad farming and how he used to evaluate soil health, just by looking at, by feel, by smelling, the soil, said, oh, it's time to plant. So we grew, some potatoes, barley, and quinoa, then after high school, and then I went to university, and then I always wanted to learn more, right? So I heard in the United States there are technologies in terms of soil management and things like that. So I applied for a Fulbright scholarship in the early 90s, and I ended up in Iowa State University. I finished my undergrad degree, and then moved to Missouri with the scholarship with my master's degree, and I graduated, I think it was in 95. Then I went back to Bolivia, and I was a teacher and instructor for 3 or 4 years before coming back to the States to work on my PhD degree. And it has been a long journey. Most of my experience comes from the work in the Midwest, Missouri, and I spent time in Ohio State for about 5 years, and then work the surrounding states. I'm going to mention more about those later. And then I moved to K-State as a faculty member. And then finally to UNL, so I'm circling, I might come back to Missouri maybe, right? So it has been a great journey and rewarding, and then I mentioned some of the things that I've done, but I would like to talk to you about this system called no-till. So before I get started, I would like, feel free to jump in any minute, even at the end. I'd like to really hear, your comments or questions, because you guys know more than me about no-till. Most of you are quite familiar, and what is this guy talking about? And you already know this. So I would like to share what I have learned in the past 30 years, in terms of research and in terms of what others have done. Because I've written reviews and I published papers. I remember working on my master's degree, measuring soil physical properties and the long-term no-till and the plow-till experiments and near Kingdom City, which is like east of Columbia, Missouri, and remember, the differences, soil properties among this system. So I want to talk to you about, how no-till can, oops.
Yeah, click on the right there.
Okay, yeah. So this is something that we all care about, right? The services we get from the soil, and we put them in groups, right? The provisioning, regulating, supporting, and even cultural. So soils provide a lot of services, and you guys know better than me about each of these services. The first thing obviously is food production. What about fuel? What about fiber, right? What about fluctuations in climate? I mean, we have frequent droughts, we have floods. Can soils, help us to adjust to such changes, right? What about carbon accumulation or carbon losses? And what about even some, landscape characteristics and all those services that we get from the soils? I mean, but how can we maintain those services? I mean, we have degraded our soils, and if we have degraded soils, we're not going to get all the services that we expect, right? So that's the question. Does no-till receive? And some say, well, of course, we don't have to tell, much about the services, and we already know that no-till works great. You might be right. You might be right. But that based on research and global literature, I see that there is more of the room for discussion about no-till benefit. When it comes to erosion, when it comes to water erosion, to wind erosion, to tillage erosion, I think no-till has delivered. Right? I think that's the reason why no-till was created, to conserve soil and water. I think in places where no-till, was established, I think we have less erosion. And tillage erosion, something that's not discussed much, and sloping soils. Since we are not displacing soil with our implements, definitely tillage erosion is probably minimal or zero, right? What about soil health indicators? Soil health indicators have been improved as well in many cases, right? We can go property by property. What about conservation, especially in water limited regions? We leave a lot of residues there on the no-till system, and that reduces evaporation, and that will conserve water. What about yields? Well, we're going to chat about those things, but in some cases, yes, it does increase yield. But what about the water pollution? How come we have been using no-till since the 60s, 50s? It has increased. What about, we keep talking about water, pollution. So what about hypoxia? What about anoxia? What about the Gulf of Mexico? So we really need to look at this, some of the challenges that we face with no-till management. What about greenhouse gas fluxes? I mean, it usually reduces CO2 fluxes, but what about others, right? And sequestration is something that I'm going to touch, carbon sequestration a bit more. Okay, so in terms of water erosion and conservation, since we are covering the soil with this nice thick blanket, so no-till, yep, does reduce erosion, does conserve water, especially if you are in need of water, like in Nebraska. I'm biased, obviously. I worked in Kansas and Nebraska and semi-arid regions and irrigated regions where we really need to conserve water. But in some cases, we might want to get rid of that water, right? Well, if we improve water infiltration with no-till, we can also improve drainage, right? Mentioned again, we have this in the upper, left corner there, from the dust ball. but now no-till is being used a bit more. So that has reduced erosion rates in the United States, right? Again, I'm gonna talk more about that the recent, surveys, but in general, erosion has decreased, right? Unless you don't manage soil, our fields properly. You have a no-till system, but you are baling residues. Or you're baling, you're removing too much residues. No-till works thanks to residues, right? If you don't have residues, then avoiding simply tillage, nothing is going to work. No-till without residues, I mean, it's as bad as conventional till. That's what I learned from colleagues and many, years of research. So we have review here. I conducted a review of global literature, and if you're interested, you can look at the paper where we have more, looked at, a good number of soil physical properties, but here listed on, 5, 6 properties. What about compaction properties? How does no-till, do compaction? So, well, it seems it's mixed, right? You might see compaction at the beginning, but as the soil recovers after many years of tillage, no-till probably is going to alleviate compaction. Compactability is something I wanted to touch. We don't talk much about that. I'm a soil physics guy, so I'm going to, talk about that. What is compactability? The soil susceptibility to compaction. What about structure, aggregate stability? So it increases. So no-till reduces the soil susceptibility to compaction. It increases aggregate stability. What about dry aggregate stability? Well, it can seem to be mixed, but no-till is going to cover the soil, right? What about increases water infiltration? It is good news. Plant available water in most cases, right? And temperature will be reduced in summertime. And in wintertime, when you have this nice, mulch layer, I mean, soils can be warmer, right? And there's no-till and plowed soil. Okay. I want to spend a couple of minutes here. Grazing is a big deal in Nebraska. I mean, we're growing cover crops and grazing to get some economic benefits from cover crop. But what about compaction? We have this, large equipment that can compact the soil. We have this equipment that, it's a proctor in the test where we compact soil, different compacted forces and different water contents. The same soil is compacted at different water contents and the different, the forces. And then we can determine, differences in compactability among different systems. And let's look at that. What is that? The green one is the no-till, and then the disc, the light green, and on top we have red. So near the surface in the upper 15 centimeters, or 6 inches, clearly there are differences among tillage systems in terms of soil susceptibility to compaction. But the short story from this busy slide is that long-term no-till management can reduce the soil susceptibility to compaction. One more thing, no-till soils in the long term can be trafficked at higher water contents than plowed soils without compacting soil, because that organic matter, provides resilience. So no-till soils can become less compactable, especially in the upper, 4-6 inches. Oops. Why is that? It's because of organic matter content, which reduces maximum bulk density. What is critical water content? Is the water content at which maximum compactability happens. So again, if you are using no-till for long term, those soils are going to be less compactable than plowed soil, because if you keep disturbing the soil year after year, then you're making that soil more susceptible to compaction. What about greenhouse gas fluxes, which is topic of great interest? Does it increase CO2 fluxes One of my colleagues, published a paper looking at the impacts of long-term tillage systems on greenhouse gas fluxes, and we conducted a global literature review looking at the impacts. And this is from this, just a snapshot from that paper when it comes to research data that yes, no-till reduces, and even reduced till reduces gas fluxes compared to mobile plow, right? Or even compared to reduced till, no-till reduces CO2 fluxes. So that's good news. Okay, so what about yields? What about crop yield? Does no-till increase yield? Now, there's a nice review out there. I mean, I can also show my own data. And from this previous study, actually, it's a nice long-term experiment in eastern Nebraska, 30-year-old, and Paul Yasa is the one that manages the experiment. And in terms of yield, it's variable. In some years, it's lower and higher and no-till compared to plow soil. But overall, there are no differences in yield. But what about if you do have cost economic analysis, and you're using less fuel, no labor, so you are saving production costs for no-till, right? So based on this nice, review by Cameron, no-till works the best in semi-arid regions, right? Because it conserves water, leaving a lot of residues, right? So under dry conditions. So definitely that could be a system that can be used to adapt to fluctuations in climate, then, right? What about then humid or high precipitation regions? Is no-till going to increase? Variable, maybe not increase, but there are other benefits, right? And if you do the cost analysis, no-till may still, outperform cloud system, right? But this is something that I want to visit with you. I mean, at the end, you can jump in with any questions in a minute. We do have some challenges with no-till. I'm talking about in terms of global knowledge or global literature. Maybe not here in Kentucky. I mean, I see that you guys have been successful with no-till. 50% of farmers are using no-till. In Nebraska, maybe 20%, 25%. So if no-till is that great, how come only 25% of farmers in Nebraska are using no-till, right? So there are some challenges. Not only management, but also political, economic, subsides. There are many reasons. But here you go. Let's just look at the data and concentration of these salt nutrients. We have no-till systems. We have reduced till systems, but the concerns about water pollution have not disappeared. We keep talking about hypoxia, water pollution, right? Is no-till reducing the concentration of the salt nutrients in runoff? And in some cases, not really. No-till is a top technology to reduce soil loss. We know that. And it can also reduce runoff. But if runoff that's leaving no-till fields in some cases can have high concentration of the salt nutrients, right? What about leaching? For example, this is a big deal in Nebraska. We have sandy soil, and then farmers use a little bit of too much nitrogen, and then that can end up in groundwater. And there are no-till systems, right? So it is a concern. And then a stratification of carbon, which is related to carbon sequestration. I've been invited to talk about, carbon, sequestration. Are we sequestering a lot of carbon with no-till system? Yes, we're sequestering maybe in the upper 4 or 5 inches, but not below. And acidification, I wanted to mention acidification, a nice long-term experiment in 20-year-old long-term experiment in northeastern Nebraska. Look at that. Let's look at the systems, continuous corn. We have 3 tillage systems, mobile plow, reduced till, and no-till. And then we have 2 cropping systems, continuous corn and corn soybean. But acidification is the worst on the no-till continuous corn, like 4.7. What about the mobile plow? It's like 6. So probably two lines, right? So there is a, that's because we apply nitrogen sitting near the surface, right? And the upper 3 inches, so that could be a concern in some cases. What about carbon? That's something I wanted to visit. That's what I've been doing lately. I mean, carbon is a key to all the ecosystem services that we, that soils provide, right? So carbon. There's no till sequestrable carbon than plow fields. Yes, we can see here the differences in surface cover. I mean, here we're stirring the soil, we're burning that biomass, so that source of carbon, right? But here we have a nice system with a mulch cover with high carbon content, right? And then, yeah, we think we're storing carbon. But look at this data. Apologies for that busy graph, but I wanted to put all the sites into the same graph. So when I was at Ohio State, I did look at paired fields. I mean, no-till, against plowed fields. So paired fields. They're not randomized, obviously. So I had 3 sites in the northern portion of the state here in Kentucky. Then I had a good number of sites in Ohio. And then in Pennsylvania, they had a good number of sites. I'm looking at carbon accumulation, in these paired fields. And in short, yeah, 1, 2, 3, the green bars are no-till. Yeah, no-till is storing carbon. Yes, 1, 2, 3, 4, 5. These bars are the LSDs. So they're statistically different. But in conclusion, no-till was better than plowed field in 5 of 11 MLRAs, right? In the upper 4 inches. What about the rest of the MLRAs? No-till actually had lower carbon, it seems, below 10 centimeters. You see how they're switching there, the lines are. So because you are burying residues with plow, you're burying some residues and reducing decomposition, right? And then what about we didn't go deeper than 60, but we did not see differences between those 2 systems there. And then another researcher, Christopher, had good number of another set of MLRAs from the same region, on 3 states actually, Indiana, Ohio, and Pennsylvania. And what did she conclude? That for the same soil depth, the no-till are similar to plow till, right, in most MLRAs. So we do have some challenges when it comes to carbon sequestration for the whole profile. But near the soil surface, no-till tends to store more carbon. So we need to look at the site specificity of no-till management, right? We tend to say, well, okay, no-till is going to work better in semi-arid regions. And that's true. I mean, that's what Pitelko showed in his review, that no-till tends to increase or increases crop yields in semi-arid regions compared to plow-till. So it should do the same thing for carbon. That's what we assume. It should increase carbon in semi-arid regions. But I have 3 sites here, although precipitation is not that low. In Hutchinson, Kansas, about 900 millimeters of precipitation. Hayes, 580, getting very close to semi-arid region. And then a semi-arid region, we have 3 sites. So long-term experiment, 23 years, 45 and 21. After 21 years in the semi-arid site, there were no differences in carbon accumulation between no-till and plowed soil, right? But in these 2 sites, yes, there were some gains. No-till was better, but that's only happening in the upper few inches, right? Okay, then after that, I said, okay, well, we need to look at this more carefully. I mean, when Humberto had a good number of sites. And what about the global literature? What do we know? A good number of reviews there. The first one by Baker, right, John Baker. Well, this no-till, it's similar to plow-till for the whole profile. What about by Govert in 2019? It says no-till increased in 50% of cases near the surface, and then but reduced in 10% of the cases. And then no-till is equal to plow-till in 40% of cases. What about for the whole profile? Lou and I mentioned that, okay, for the whole profile, we do not see any differences in carbon sequestration. So again, no-till is doing a pretty good job near the surface in most cases, but it's doing a poor job for the whole profile. I mean, when it comes to carbon sequestration, okay? So again, this is what they said, it can store more carbon near the surface, but not below. But beside the specificity, no-till could accumulate carbon, but we need to really identify those croplands and marginal lands where cover crops can store. I mean, we have, well, I mean, but no-till can store carbon. I mean, we have a good number of reviews right out there that questioning no-till management. So this sometimes it makes me think about really about the real benefits of no-till for carbon sequestration. But again, no-till has delivered a lot of ecosystem services. So this leads me to this. No-till has accomplished what it was designed for. I mean, no-till was created. Why was no-till invented? It was invented to to reduce erosion, to conserve water, right? It was not designed for carbon sequestration. So if we expect no-till to sequester carbon, then I think we need to modify that system. I think we need to make some adjustments so really sequester soil. We can deliver one more service consistently across all soils. So we need to identify where and when these systems can sequester carbon, right? And so these are the factors we need to look at, right? What is the climate, right? What is the carbon saturation level? If the soil has enough carbon, like near what's in the textbook, 5% organic matter, but there's not enough room for no-till to do its job. No-till can work probably better in soils that are in need of carbon. Degraded soils. How long has no-till been using? 10 years, 5 years, 20 years? What about texture? Right, the texture. I mean, what about the clay content? What's the sand content? Right, the topography, slope. There are so many factors, right? How does texture affect? I mean, there is a nice review in this one saying, but you know what? No-tills usually accumulate more carbon in what? In medium texture soils. What about if you have a clay soil, silty clay loam or sandy loam? The benefits of no-till might be limited, right? What about slope? I mean, here in Kentucky, you have nice rolling hills. In Ohio, when I worked in eastern portion, the state in Nebraska, we do have some rolling hills. Well, slope is a key factor. Slope is a key factor. I mean, we don't want to generalize, but most of the back slope, the eroded portions of the field have low organic matter content at the foot slope, right? So those spots can store more carbon, right? Look at this paper that Ivan Thaler published a paper, right? And Proceedings National Academy of Science saying that we are losing a lot of soil. We have lost a lot of soil in the Midwest. And he's photo here, look at that. So probably we expose the V horizon through losses through erosion, could be water erosion, wind erosion, tillage erosion. Those are the spots probably can work for that for no-till systems, right? So I think we need to really look at not only soil texture, but also slope. So what systems can gain the most? If you have a low carbon system, and if you have an eroded, a sloping, a medium texture, I think that's the sweet spot for carbon accumulation. So this is what we are after, depends where you are. This may not really, it may not apply 100% to Kentucky soils. But in order for Nebraska and other certain parts of in the world, we need to move to the next step. I've been using no-till for 40 years or 50 years. Well, it has not delivered all the services and seems there's some challenges. What about the next step? What about combining with cover crops? What about for the continuous cropping? I'm not talking about this monoculture. But what about intensifying of the cropping system? What about maybe using biochar? Or what about animal manure? Or perennial grasses? I learned from Gary Peterson, retired professor from CSU, saying if you don't put the forages in your no-till system in the Great Plains, I don't think you're going to sequester any carbon. And he's right. So we really need to make that system work. Where in spots where no-till is not working. Look at the amount of carbon sequestered by different. This is this kind of averages that no-till can sequester that much. That's an average number. What about crop rotation? Continuous and sequester. Cover crops can sequester that much. Organic farming. What about some perennial species? If we combine this, that can work, right? Probably not all of them, but 2 or 3 of this can improve no-till performance, right? Well, no, it's easier said than done if you pair no-till with cover crops. In some cases, like in Nebraska, where we have continuous corn or corn soybean, you plant cover crops in October, then harvest, and you kill in early April. That's what you get. Less than, it's like 0.3 tons per acre. But in Kansas, where we have, this wheat sorghum, we planted cover crops after, winter wheat in July. This is what you get in late fall, like about 3 tons per acre. That's the sun hemp. It's a lot of biomass. What about here in North Platte in western Nebraska, west central Nebraska? We are getting about 4 tons, but that was planted after cold silage. This is winter, right? So if you plant early and cover crops in late August, then you kill the following spring. This is like in early May. That's what you get. So that's about 4 tons, right? So it depends on management. You tell me which of these soils have more carbon? I mean, can we tell this by looking at the color? Which one has more carbon, you think? Or cover crop? The one on the right, yeah. So we can look at like there's an experiment that I had in Kansas with that system I showed with this one. By just looking at the color, you can see that you're accumulating carbon, right? There you go. So now no-till alone is here, business as usual for some farmers. Business as usual, red. That's one step. I mean, you made the first step. What's the second step? Well, we need to add cover crops. Okay, I think now that, right, the one on the very left was organic carbon. There's organic carbon, increasing organic carbon. The earthworm population is increasing, right? And then you are increasing what cumulative infiltration. Statistically looking at might not be that the difference between soybean, which doesn't produce as much residue as sun hemp, but look at the sun hemp really improve the potential of no-till to sequester carbon and to improve soil physical properties. What about adding perennials? I mean, what about adding perennials? Well, look at the perennials. This photo is not from the same field, but here we have switchgrass, right, which have deep roots. And the recent paper, they're talking about the benefits of, cancer. Well, these deep-rooted crops can fit probably in our systems, where we can sequester carbon, right? These perennials can be established in marginal spots, compacted soils or sloping soils. I mean, we're not replacing the cornfield, but each cornfield has a problem. I know that based on my experience working with farmers, and I haven't found a farmer says I don't have any issues in my farm. There's always low production. That's a low producing area in my field. That's where I put this. What about center? Where are you getting for the center pivot? What about the corners? The corners do not get enough water, right? And we can put this switchgrass or the warm season grasses there to sequester carbon. So, what did we, discuss? Overall, what can we learn about this? It's no-till, yes. I use that word there. Can. It delivers a lot of services. It has accomplished a lot. Okay, so benefits, reduced production costs, right? Increased, conserved water, increased crop production, especially in dry years, and improve some soil health indicators and reduce CO2 fluxes, right? Those are great benefits. A lot of services. But what about in terms of carbon sequestration? That seems to be unclear to me. I mean, it's not there, but it accumulates near the surface, which it could be beneficial though. It accumulates carbon in the upper 4 inches or 5 inches. That carbon is essential for improving soil properties. I'm not talking about that here. No-till is a win-win scenario when it comes to that. I'm talking about for the polar please, maybe 60 centimeters or 1 meter is what we have. Because that's what we want to sequester, right? To increase the residence time of carbon. Because the carbon concentrated near the surface soil can be lost easily. But the site specificity depends on your farm, depends on the management, right? Okay? I think that, no-till needs some assistance in some cases. Based on my visits today with some of you, I learned from Kentucky soils, no-till, they're doing overall pretty good with no-till. But in Nebraska and other places I've seen, no-till needs some help. Because simply parking the steel is not working in some cases. So it's not just avoiding disturbance. You need to do 3 more steps. Make that system work, right? So what does it mean? Well, you need to redesign the system, right? For your farm, because we cannot copy. If you copy from your neighbor, a lot of times the soil type is different between those two, farms, right? So then they talk about no-till used for to mitigate climate change. What I would say is no-till is a win-win, practice for adapting, but not for mitigating based on what I've seen in terms of carbon sequestration. But yes, what about doing mild droughts that can conserve water, right? So it increase water infiltration that probably can minimize the impacts of flooding, right? I'm here to promote no-till for a lot of reasons. Blanco, based on the research work that I have done, based on the reasons in bullet point 2, we should be promoting no-till. But when it comes down to sequestering large amounts of carbon and then mitigating climate change, and I think no-till needs some help. That's all what I can say. It needs some help. It might not need any help in your farm. You might be doing great, but what about others, right? I've seen no-till fields that could be as erodible as plowed fields. Drew Lyon in Nebraska, and I moved from K-State to Nebraska, said, Humberto, you talk a lot about no-till, but I've seen some fields around here, that dust is blowing as much as from a plowed field. So because we're not producing enough biomass, right? So what makes no-till work is just a cover. But sometimes we don't have enough cover. We might have enough cover sometimes, but we don't have probably a lot of deep-rooted systems there to sequester carbon at deeper layers, right? Well, that's all what I had for today. Thank you for listening, and I hope you have enough time for questions. I will really listen. I can learn and try to answer some of the challenging questions that you may have.
Great, thank you. Do we have questions?
No questions? I go ahead.
So what research have you done in animal systems and grazing systems
Mhm.
with no-till versus conventional?
We have, in terms of crop residue grazing, and then cover crop grazing. Yeah, so Nebraska, it's a, having enough feed for cows is a big deal. So we have looked at how residue grazing and cover crop grazing and their no-till systems affect, soil health indicators and erosion, all those ecosystem services I mentioned. And in short, we have not seen any negative effects of grazing residues or cover crops. I mean, we are grazing, the farmers are grazing for 15 days or for, 1 month when the soil is frozen and, maybe cover crops, not growing when the soil is frozen, but like in early spring, just for a few weeks. I mean, a lot of farmers are concerned about compaction, traffic. But based on our research and some reviews, we have seen that no, there are no negative effects of, in general, no large negative effects of grazing, residues or cover crops on the no-till system. And I haven't done cloud, so I don't think it will work better than cloud. I don't think we can reach the same conclusion on the cloud systems. Yep. Yes, John.
What level of residue removal during grazing is considered optimal? Like a third of the residue, 20%? In that short 15, 30-day window, what level of residue removal are you achieving?
Excellent. So that's a very good question. Cows usually remove the 20 or 30% of residues. I mean, with the baling equipment we have, we're removing 60, 70%. I mean, we don't have a equipment that removes 10%, 20%. So that we're removing with grazing 20, 30%. So, but our recommendation is that you should leave at least, 2 or 3 tons, at least 3 tons of biomass per acre. That's the rule, threshold level, because we need to establish threshold level for each ecosystem service. So on average, maybe 2 or 3 tons of, corn residue should be left, to maintain the soil services. So, yeah. Yes, sir.
One question. So I get the impression from this relative equality of conventional till and no-till that here and there one system may outdo the other system in terms of carbon accumulation. It seems to me, also having sandy soils in mind, where we learned that farmers use the plow in order to mix more organic matter into deeper layers, and that way to increase the fertility of sandy soils. So it seems that one problem that can help us to increase the carbon accumulation in soils is to bring residue and so organic sources in contact with the mineral soil body. So if we can also do something in the temporal domain. One thing that comes to my mind, so I'm sure you have, besides this question mark, you have already an exclamation mark, right? So on your mind. So what about helping with additional resources to keep the carbon over a longer time period?
Mm-hmm.
What do you consider the opportunities that may come from nitrogen, from adding nitrogen, not in the way that we have done it in the past, because that can lead to huge losses. Simply, that's my opinion, because we apply it not often enough at small rates, but we apply it only a few times at high rates. So how do you see any potential in doing a better job in nitrogen supply, in the timing of nitrogen supply, to avoid the environmental footprint of nitrogen application, but to have the benefit in fixing carbon in the soil?
Excellent question, Ole. Yeah, a couple of things there. One is we need to, put that carbon deeper in the soil. I mean, how can you do that? That's probably through, easier to say, but in some deep-rooted, crops. I mean, that's one way of doing it. Like why not having alfalfa in the system Well, that will grow deeper. What about some perennials? I mean, we really need to redesign the system, because if we just gonna, can corn soybean, then that's not doing a great job, really. Now, if we nitrogen, I have a couple of reviews there that nitrogen does not increase does not sequester more carbon than fields without nitrogen. I know nitrogen fertilization increases biomass production, right? We know that. It increases grain production. Because thanks to nitrogen fertilizers, we have doubled the production, and we have doubled biomass production too, right? So it should store more carbon, but in some cases, probably, I would say even in most cases, does not sequester more carbon than no nitrogen. Why is that? Because you have a lot of nitrogen, you are increasing decomposition, and that biomass for some reason just disappears. Now, a split application, like a split application, applying small, amounts may be more efficient, right? Than just applying everything at once, because we lose a lot of that to the atmosphere, to the groundwater, yes, or runoff in some cases. So, yeah, there's a potential. That's why we have researchers now looking at this precision agriculture and the application at the right time, at the right depth, and things like that. There's an opportunity to explore that a bit more, instead of just dumping a lot of nitrogen at once. Yeah, that's a loaded question, but we need to really redesign the system if you want to make no-till sequester carbon. But I don't want to sound today that Humberto is kind of against no-till. No-till has delivered a lot of things that what the system was designed for. But now we are trying to link no-till with carbon sequestration and climate change, mitigation. Well, in that case, it's questionable. Yes.
I guess thinking about the role that no-till could play in increasing soil carbon, like maybe in the western states, have you found that the no-till benefits like intensification of the rotation, like eliminating fallow periods and the water storage?
Yeah. So it reminds me of work done by Gary Peterson, he retired from CSE, he was a professor at UNL as well. So he, always against the crop follow system, we need to intensify. And then he did that, and one of his papers, he said that 50% on carbon increase. Definitely that follow period needs to be reduced. I mean, in the Great Plains, we have 14 or 16 months of follow period where soil, we consider soil like it's dead. There's nothing growing there, right? If there are weeds, chemical follow. So 16-month period. I mean, we need to feed that soil. I mean, if we want to sequester carbon, we need to grow, we need to put more roots. And so we need to intensify. That's with follow. During follow, we need to put some forages or cover crops, right? To really, reduce. I'm not saying get rid of follow, it would be nice, but it's not realistic. But at least reduce that window, maybe from 6 months to 6 months, maybe, or 16 months to 6 months or less, right? So Gary Peterson has done some work, or John Holman now is doing some work we have done in Garden City, where he has a wheat follow, and then we put we call forage, crops there during follow period, and they use that for haying or harvesting, and still gaining a lot from roots, So that's that's one of the the strategies we can use. Yes.
Yeah, over the last year and a half or so, I've been working on the Colorado-Kansas border with RCS, and we've been kind of promoting a lot of what you're talking about, mixed species cover crops in those fallow periods.
Mm-hmm.
And we've noticed that farmers who are also ranching have been a lot more apt to adopt these practices, and they've been seeing a lot of benefits on providing animal feed in those fallow periods, and traditionally, that's not been grown.
Yeah, one attractive aspect of that is grazing, haying, because there's no benefit to cover crops if you don't get any income in the short term. I mean, you can shine on your talks about soil health benefits, but there is no direct benefit, right? But now grazing or haying, I mean, that's something that if you're not going to remove all the biomass, I mean, you know, that if you graze for a couple of weeks and 1 month, you're still leaving, a significant amount of residue on the surface, and then you're not grazing the roots, right? So it's still a win-win, scenario there. So that has a potential, it has potential to improve not only, soil, but to sequester carbon, and crop follow systems. Yes, Jim?
The ongoing drought, which has been very significant
Mhm.
in the arid and semi-arid West. Do you see that actually bringing back more fallow? Because there's this need to harvest water over a greater period before you grow a cash crop, or no, they're going to keep on with practices that Gary and others have brought on. What's going to happen here if this drought keeps going?
That's $1 million question, right? I mean, we have to be opportunistic, opportunistic. If it's really dry, I mean, nothing will grow, right? I mean, so what about just growing up, something up, a portion of that fallow period? Remember that the precipitation storage efficiency of crop fallow is it's very low. I mean, we are accumulating 20-30% of precipitation. What happens with 70%? It's gone. So we are not storing all the precipitation during fallow period. We are storing only 30%. And most of that precipitation storage efficiency occurs in winter time. So if we grow something during winter, we can, use that 70% of water, right? But cover crops can, use water in semi-arid region. A lot of people hate cover crops because they're going to use water and reduce yields of the subsequent crops. But cover crops at the same time provide cover. I mean, so they can offset. So if it's a mild drought, I mean, cover crops can improve water quality in the, in the long run by adding organic matter. But if it's like severe drought, no, I mean, cover crops are going to make things worse. So, I mean, in that case, we really need to, even cover crops are not going to work. We really need to find another, system or develop another system that can withstand against droughts. But adding biomass somehow, the years before, upcoming droughts will help, because organic matter is key to, maintain or increase plant available water. I mean, there are papers out there saying organic matter content does not increase the level, but it helps. It's going to help some. So that's. If I know the answer for that, for sure I would get a better position, right?
Okay.
Thanks.
Proud.
Oh, yeah.
Maybe, Bonzi, let's just take a look at the chat. We'll give Zoom a chance to.
Yeah, thank you.
Yeah,
Rebecca. No.
all right.
Yeah.
Monthly.
There?
My question is regarding the effect of no-till on crop yields.
Mhm.
I have a conclusion that about a positive effect of no-till in relatively drier years, which I think is consistent with what we see here.
Mhm.
And then you also show results about differences in carbon accumulation that were dependent on the precipitation, with drier years not showing differences in carbon accumulation. So my question is if you will expect or have seen that there's then a benefit, relatively more benefit in dry locations that are more water limited because of reduction in soil evaporation, increased filtration, or if the benefit in terms of yield is only on relatively drier years of relatively more humid sites.
Yeah. So no-till, yes, usually increases yields, and Alan Schlegel is one of my colleagues from K-State that says, Humberto, no-till is always out yielding here throughout my western Kansas. He retired last year, a couple of years ago. So in general, yes, no-till will, produce more yields than plowed soils in semi-arid regions. Now, what about carbon? So again, that's what for carbon, even in semi-arid regions, no-till struggles. I mean, against plowed field. Again, no-till was not designed to store carbon in semi-arid regions. It was designed to reduce erosion and conserve water. So if it's going to conserve water, then it's going to increase yield, right? So that's one of the reasons that no-till is increasing yields. But when it comes to increasing carbon, I think we need some forage crops there in your no-till fields, right? Or do something to increase carbon a bit more. I mean, I know carbon, organic matter content on those soils are relatively low, right? So there's room for accumulating, but we need more crops and forage crops, assuming that we have enough water, right? That's why we need to be rather think about flexible rotation, Like when it's going to be a dry year, maybe you need to switch. And that's when you need those models that can predict the future, right? I mean, that's what it's needed to manage the system. Did I answer your question? Or yeah.
Yes, so in dry locations, there's still an advantage of no-till.
Mhm.
So that will lead to more carbon accumulation, right? From
Yeah.
the byproduct.
So you mean here in Kentucky?
No, in relatively drier sites where no-till doesn't lead to differences in organic carbon.
Uh-huh.
In those sites that are more arid, where there's no differences in organic carbon, you still see an advantage in terms of yield because of reduction in soil evaporation, better infiltration, more water for the crop.
Mm-hmm. Yeah, definitely. But I guess but we really need to think about improving that. We're talking about small, differences. We need to go beyond that. That's what I've been pushing, redesigning that system. I mean, we need to think, beyond that, really. I mean, not just as a small differences. But that's a great question. But I don't have to, the recipe for that. But all what I can say is. Don't quit. No-till is great. Don't change your system. Don't go back. But I think we need to help that system to even work better. In some cases, even like I read some papers from Kentucky. Said, no, it's not making. We already know that no-till works. We know that. But that's not everywhere. And in Nebraska, for example, no-till needs some assistance to perform better, and it's going to even need more assistance in dry region, to do that.
Well, great. Thank you so much, Humberto. John, do you want to come up, a nominator, and take a photo, or you want me to do the honors? We have this very pretty plaque for you to take home and put it in your office of choice, either on campus or in your home. We certainly appreciate you coming here and sharing your expertise with us. And we hope you have a nice visit.
Great, thank you very much. Oh, okay. Show my this side, then.
It's on the -20 pound silver here.
Yeah.
All right, so thank you all very much. Feel free to come up and say hello. Have a great weekend.
Well, thank you very much for this. This is a really great honor, and thanks for showing up to my talk. I'm again impressed by all what you guys have done in terms of no-till management, and this is a testament to that, right? So, thank you.
You're welcome.
Thanks for the photo.
But I think it's. No,